complete one oscillation. So if this is a sketch of the ticker timer drops, so you can say that this object is accelerating when the gaps are increasing. When the gaps or when the holes are made at a wider gaps, then the object or the moving tool is being accelerated. So that means that the direction of motion is this one for it to have an acceleration. So that initially you had these ones. When they are being pulled, they are now increasing. But if the direction of motion is in this direction, then you say that it is decelerating. So the initial velocity for acceleration is now this one. So the distance is 12 seconds over the frequency. We can say that the frequency can be 100 as, remember, time to complete one dot is 1 over frequency. That becomes time is equals to 1 over 100 as 1 over f. That gives you 0.01. Therefore, initial velocity is now the distance over time taken to complete that initial velocity, which is now 0.01 times the number of complete oscillations. We have here 1, and then you have 2. So therefore, it's times 2. That gives you 12 divided by 0.02, which leaves you with 600 centimeters per second. So this one can also be converted to SI unit if need be. Then final velocity is for this one. So the distance for final velocity is 32 centimeters, then divided by, so also time is 1 oscillation, 2 oscillation. It's still the same period or the same oscillations. So that is 2 times 0.01, and that gives you 32 divided by 0.02, which is also 1,600. So how about acceleration? So acceleration is given by the final velocity minus the initial velocity over time taken for the change in the velocity. So therefore, we are using this one. This is in terms of centimeters per second as well. That is 1600 as final velocity minus initial 600, then divided by time taken for change in velocity. That is, time taken for one oscillation has been found to be 0.01, but times how many oscillations? So oscillations, you now go back here. So the mid of the initial velocity is at this dot. So we are starting from the mid of the initial velocity up to the mid of the final velocity, which is this dot. The mid is this one. So counting the oscillation, we are moving from here, this one oscillation, this is second oscillation, third oscillation, fourth oscillation, fifth oscillation. Therefore, it is times 5 oscillations. That now gives you an answer of 1000 divided by 0.05. That leaves you with, from the calculator, that is 20,000 centimeters per square second. We can also convert it to meters per square second. Remember, centimeters is simply divide by 100. That gives you 200 meters per square second. As simple as that.